our final exam review for the fall of 2024. So we're going to write the explicit and recursive equations for the sequence. We need to first analyze how we're jumping from one number to the next. This looks like a multiply by 5, and it's all the way through multiply by 5. So that means that the common ratio is 5. It starts at 2. That's all we need to know. So explicitly, that's f of n equals, starts at 2, multiplied by 5, to the n minus 1. Recursively, we state it starts at the first term is 2, and then the previous term times 5. Of course, that 5 could be out in the front, it could be in the back. It all depends on what you see. Okay, now we're going to do that for an arithmetic sequence. So 3 goes down to -1 by going down by 4. 1 minus 4, -1 minus 4 is -5, and -5 minus 4 is -9. So the common difference, D, is -4. Explicitly, we set this up as f of n equals, where does it start? It starts at number 3. We move by 4s and times n minus 1. Recursively, f of 1, it starts at 3, and to get the current term, you take the previous term and subtract 4. So previous term, subtract 4. Find the missing terms of the arithmetic sequence represented in the table and write the explicit and recursive equations. So the missing term is basically how far is this as one big jump, and how far is this in one big jump, and then we're going to divide it up. So to go from 6 to 50, you have to have jumped a total of 44. And to get there, you have to have jumped from 1 to 5, which is a jump of 4. That means the common difference is 11. So that makes this 17, and then 28, 39, and then 50. So the explicit equation is that f of n starts at 6, and we're going to add 11, n minus 1 times. Recursively, f of 1 is 6, and then we're going to put on to that to the previous term, you add 11. Now, when we get to a geometric sequence, it's a little bit different. So we start with the first term. We look at how many jumps we have to take. 1, 2, 3, 4. So that's the common ratio 4 times. And that's supposed to equal 3194.1875. We divide by 7. R to the 4th is 3194.1875 divided by 7. 456.3125. To solve for the common ratio, we take the 4th root, or you can take it to the 1/4 power. So I'm just going to do a 4th root on this. That means the common ratio is 4.62. Now it does continue and have some more decimals. So if we're going to round this off, we're going to be introducing a small error each time. You have to be able to live with that. So that means that these numbers are 7 times 4.62 is 32.34 times 4.62, 149.41. I rounded that, and that times 4.62, 690.28. Now, if you multiply 690.28 times 4.62, you won't quite get 3,194 where you were supposed to have landed. That's because we had to round off. So don't be worried if you have a multiple choice test coming up. There's only going to be one answer that's anywhere near what it should be. Okay, number 9. Alexa landed a job as a financial analyst. She's going to make $95,000 a year. That's her initial value, her starting pay. And the company guarantees her a 3% pay increase. So that would be 1.03 is the common ratio. At the end of the first year, she's going to make $95,000. So the explicit function can look like this. It is exponential. Number 10. The first term in a sequence is 112. The sequence decreases by 7% each term. That means if it loses 7%, it's retaining 93%. So that would be 0.93. And then what is the 18th term in the sequence? Well, remember, that's got to be 18 minus 1, because 112 is the first one. We don't want to multiply it 18 times. We want to multiply it 17 times by itself to get the 18th term. So in other words, this is 112 times 0.93 to the 17th power. Okay, and that is 32.62. I have to round it. Oh, nearest thousandth. Hold on. 32.616 to the nearest thousandth. Number 11. Which is the explicit function, or what is the explicit function? Well, look at the slope. You're going down 3 and over 1, down 3 and over 1, down 3 and over 1. So the common difference is -3. You're starting at 9. So f of n is 9 minus 3 times n minus 1. Number 12. Here's the recursive graph the first 3 terms. Well, first let's figure out what the first 3 terms are. Actually, that would be n and f of n. So we're going to begin at 1, and you get 1. It says so right here. At 2, you're going to have multiplied by -2, so this will be -2. Right here it says multiply by -2. On the third term, you're going to have taken -2 and multiplied it by -2 again. So that would be 4. Let's put this in the middle. So 1, 1. 2, -2. And 3, let's see, 2, 3, 4. 3, 4. This thing is changing sides of the x-axis as it goes along. Number 13, a sequence has an explicit equation. Here it is. What's the recursive? Okay, so I need to know, where does it start? If I put n equals 1 as the beginning, that would be 4 to the 1 minus 1 is 4 to the 0. And then 4 to the 0 is 1. 5 times 1 is 5. So this thing starts at 5. And then to get the next term, I'm going to multiply by 4. 4 is the thing that I'm putting as an exponent. That's the thing I keep multiplying by. So 4 times f of n minus 1. Number 14, Monique started a savings account by putting in $250. First week she deposited $100. This is going to be positive 17. Plans to continue depositing 17 each week. So f of n is going to start at $250. I can do better than that. $250 and is going to increase by 17 n minus 1 times. Number 15, what sequence models the perimeter of the following figures? The word perimeter means all the way around the outside. So in figure 1, you go 1, 2, 3, 4. In figure 2, you go 1, 2, 3, 4, 5, 6. In figure 3, you go 1, 2, 3, 4, 5, 6, 7, 8. So it's the sequence that goes 4, 6, 8. Now, I don't think that on the final that's going to be asking you for the explicit equation, but that's what perimeter means. Number 16, that is linear. Made a mistake here. Didn't notice that the last jump on the x is 2 and every other jump is 1. So this would be a neither. Number 18, Gabby starts arranging her M&Ms into rows. The first row has 24 and each row below has 3 less than the one before. There's a common difference, -3, and so this will be linear as well. This one is a neither. It's not linear or exponential. 20 is clearly exponential. It has the correct format. And this is a recursive equation of something that, because we're subtracting 8 each time, is linear. So how do we write number 22 in the root form? Well, we take the 5, which is the denominator, and put that as the root. Then everything that's left just goes underneath the root. So the 2 that was there and the 6 that was there. Number 23, write the simplified radical form of this. Okay, so inside of here, so you have a 5th root, and inside there's a few simplifications we can do. So for example, a to the 13th on top, a to the 2nd on the bottom, we can subtract that. That's 13 minus 2, or a to the 11th. And then for b, you can also subtract 7 minus -1 is going to be plus 8, or positive 8. And that's b to the 8. Now, I think the final exam is going to be such that this stays the way you do it after this step. In other words, there's some more simplifying that could be done here, but I don't think it will be done on the final exam. And then 24, the equivalent radical form. Okay, so when you have this power on the outside, the 1/3, you get to multiply it times the other powers. So it's... Unfortunately, I didn't multiply it correctly. So I'm going to drop the correct answer in right here. $25. Okay, this 26 here is out of place. 25. Place a dot on the graph to represent the 4th root of 3 to the 2nd power. Okay, the key is to take this and convert it. 4 to the 3 to the 2nd power. Okay, that's going to be the 1/4 power is the 4. So 3 to the 2nd, 1/4, and that's going to be 3 to the 1/2, or 2/4, which is 1/2. Well, this is the function of 3 to the x. So the x is 1/2. So if you go to the x of 1/2 and go straight up, right here is the point we're talking about. So it's 1/2 here on the bottom. And by being on the graph, it's the power of 3. Okay, 26 says, place a dot on the graph to represent 3 to the -3/2. Well, -3/2 is equivalent to the same as -1.5. So if you go left 1.5 and straight up to the graph, you're going to be right about here. Right about here. That's -1.5. The key, though, is that it's on the graph. Okay, we're going to use this graph for problems 27 through 30. 27, where is the y-intercept for the graph? It is right here, and that is 0, 0. 28, name an interval of increase. There's a couple of them here. One of them goes from -5 to -4. So that's one possible answer. -5 to -4. But you probably saw this other one out here. And that one goes from an x of 2 until 8. 29, where is the maximum of the function? Let's see, right back, I'm getting the highlighter right back here. There's the maximum. And that point is -8, 4. And then finally, how many x-intercepts does the graph have? Okay, let's count them up. It's got 1, 2, 3 x-intercepts. Now we're on the last page of the review. Just some quick algebra skills. So for number 31, we're going to take away 13 from both sides. And there's a 0. That makes m equal to 9. For 32, we're going to add 2. And that makes x equal to 18. For 33, we're going to multiply by 18. Both sides of the equation. 18 times -12, -216. And finally, 34, we'll divide by 4 and get -4. 33, find the slope of the line. Slope here goes down. How many? 1, 2, 3, 4, 5, 6. Oops, too far. 1, 2, 3, 4, 5. And over 2. And it's down. It's -5 and over 2. So -5 over 2. And we can do the same thing without a graph by looking at the numbers and subtracting. So I look at the change of the y's. So y changes from -14 to 13. And at the same time, x changes from -8 to 9. So -27 over -17. That doesn't go evenly, but we can take the negatives and make them both positive. That's 27 over 17. Okay, now we have exponents. Remember, treat the numbers with the numbers the same way you always treat numbers. 4 times -2 is -8. Now for our exponents, p to the 4th times p to the 3rd is p to the 7. You add them together. 38 is -3 x to the 3rd times another -3 x to the 3rd. So this is going to come out to be +9 x to the 6th. And of course you can figure out x to the 6th by doing 3 times 2 at the beginning. 39, the negative in front of x to the 4th is really like the number -1. So you could call this -2. But then now there's more x's on the bottom than there are on the top. There are 3 more on the bottom than there are on the top. So we're going to leave it like that. And our last problem. 2 times -3 is -6. But with the exponents, you're going to add 3 and 3 together and get 6 that way. Well, there we go. I wish you the best. See you later.